Welcome to IMS Gate Academy. I am Atul Negi, faculty at IMS Gate Academy. So, in today's session, I will be discussing the most important topic of theory of machine subject for mechanical engineering students, that is vibration. We'll be talking about some important PYQ questions that you need to first revise it and learn the concept of the vibration. And this is a most important topic in theory of machine subject. Every year you will see there is a questions coming from this particular topic. So this session is very important for all mechanical students who are preparing for the gate examination. I hope you will enjoy this session and you will be getting so much clarity about the vibration numericals, what should be the right approach required to solve the numerical on the vibration topic. Right, we will discuss the approach first of all, and then we will see how to solve the previous year questions that came from that particular topic. I hope everyone is doing great in the preparation part, and in the last 3 months, this is the right time you have to switch the gear. In this last 3 months only, you have to give your best efforts to get the best result out of it. Right. So we will be coming up with more sessions which will help you in your preparation part. So let's get started here, everyone. We'll be discussing first of all a very important concept here, that is undamped natural vibration. The concept that we are going to use here is the Newton's second law only. With Newton's second law only, we will be writing the equation of motion. That equation of motion is very important to understand. Hi Matan, a very good evening. So that Newton's second law only we are going to use to write down equation of motion. With that equation of motion, we'll be getting the natural frequency and also the time period of oscillation. These are two important parameters that is what required in the vibration analysis. We'll be talking about the first case in which damping is not provided. That's why I've mentioned here undamped natural vibration. In the next case, we'll be talking about damped vibration as well. So how to deal with those situations and how to write equation of motion, that is what we are going to learn today. And we will apply those learnings in the previous year problems. Okay, so let's get started. We'll write first of all undamped natural vibration case. So let us consider a case here with no damping provided. So spring mass case I am assuming. This is our spring mass case. Assuming it to be in under static equilibrium condition. I am assuming this mass to be under static equilibrium condition. So let us mention that static equilibrium condition like this. And if it is under static equilibrium condition, I hope everyone understand that the downward weight component would be balanced by the spring force. It would be balanced by the spring force only, right? Now, so under static condition we can mention under static equilibrium condition we can write like this, mg, that is the downward force, equals to spring force, that would be equals to stiffness multiplied by the deflection. Mg is the downward force that would be acting, it would get balanced by the spring force acting in the upward direction. K is the spring stiffness, delta is the deflection, or we will say it as a static deflection. That is very important part. Delta is our static deflection that is there in the spring. So this is a very important relation here. Okay. Now the vibration will start in this case if I provide a disturbance to it. Initial disturbance is required to initiate the vibration. As of now, it is under static equilibrium condition. There is no vibration here at this moment. If I provide initial disturbance and then release this mass, what will happen? It will start moving in vertical direction. That is what the repetition of motion, which is also called as oscillation. Right, so these are like very important point that we need to observe here. So that initial disturbance would be required. Now assume that there is a disturbance provided to it, and that disturbance from static condition provided is x. After providing that disturbance, we will draw its free body diagram and then we will do the analysis. Either I can use Newton's second law or D'Alembert principle. So actually from both the concepts you will get same answer only, right? So let us consider the free body diagram here for this particular block. So this would be the free body diagram. The downward force that would be acting is its self weight, that is mg. That mg self weight will be balanced by the spring force, that would be k delta. Okay, delta is already the static deflection, it is there in the spring, but because of the deflection provided further, the disturbance provided x, now the total spring force would be k into delta plus x. Already delta is there in the spring. After the static equilibrium condition, further we have applied x deflection there. So total deflection would be delta plus x. So you will be writing k delta plus x. That is the total spring force, right? So mg is the downward force, this is the spring force that would be there in the spring. Delta was initially it is having, then further x we have provided the disturbance. Now if I have to use Newton's second law, what I will be writing? I will simply write the Newton's second law, that is net force equals to mass into acceleration, right? So according to Newton's second law, of motion, the net force equals to mass into acceleration. Net force equals to mass into acceleration, right? Now that net force would be mg minus k delta plus x. So mg is already there in the downward direction, minus k delta plus x equals to mass into acceleration. That acceleration can be represented as x double dot, that is d2x by dt square only. Clear this equation? Now further if I simplify this equation, mg minus k delta minus kx equals to mx double dot. Now already this point it is clear that under static condition mg equals to k delta, it will be always equal. So this value will get cancelled out. So finally equation of motion you will be getting as mx double dot plus kx equals to 0. This is what we have as equation of motion. Same kind of analysis you need to do for all other situations that might come in the gate examination, but the process will remain same, right? The main part that you need to focus here is the process, how I've considered the free body diagram, how I've used the Newton's second law, and finally this is the second order differential equation for the motion we got it. Okay, so this is very important part. Now here let us put this equation in the brackets, and then further we can write that x double dot plus k by m into x equals to 0, and that k by m is actually omega n square. That k by m value is nothing but the omega n square value, right? So if I have to write it here, let's suppose if I write it here, that equation becomes x double dot plus omega n whole square into x equals to 0. This is what the format that we need to remember. So x double dot coefficient is 1, and whatever the coefficient you will be having with x, that will be omega n square. Clear? So that will be the very important relation here that we should remember. Coefficient with the x double dot will be 1, and whatever coefficient we will be having with the x, that will be called as omega n whole square. So omega n value based on this equation would be written as under root k by m. That is k by m radian per second. I hope this equation is clear to everyone. This is a very important point in the analysis of undamped natural vibration case, this equation. X double dot plus omega n square into x, omega n value under root k by m. This is a very, very important relation, right? I hope this is clear to everyone. Now, what we will do, we will see the other approach also. Other approach basically means the D'Alembert approach. In D'Alembert approach, what we will do, we will also include the inertia force and then we will add all the forces. And then if you add all the forces including inertia force, answer would be 0. That is what D'Alembert principle. If you add all the forces including inertia force, then the answer would be 0. So that equation given by the D'Alembert only. So it is nothing but we have used Newton's second law in a different perspective. So you might get a feeling that all the forces summation 0, it means equilibrium they are talking about. No, actually it is not an equilibrium. It is under motion only, how the equilibrium would be there. But we are assuming there is some inertia force. If it is applied on the body, then the body might come in equilibrium. And through that perspective, we are writing the equation. So we have just changed the Newton's second law only. Answer you will be getting same. Either you will use Newton's second law or D'Alembert also. So let us see that D'Alembert approach as well. Okay, I hope this point is clear till this point. We have written this equation here. Okay, from here we have written this one. Right, now moving to the next part. Okay, apart from the natural frequency, time period of oscillation or frequency in hertz they are asking. So that relations also we should write. So first omega and natural frequency we have written under root k by m. Radian per second. Then frequency in hertz, that would be written as omega n by 2 pi. Unit is hertz. Hertz basically means number of cycles of oscillation per unit time. Hertz basically a representation of number of cycles of oscillations per unit time. Okay, so this point is also very important. Number of cycles of oscillation divided by time, per unit time basically, number of cycles. So if 5 hertz is the value for the frequency, it means 5 cycles per second per unit time. Per unit time basically means per unit time, that is second. In 1 second, 5 cycles are happening. If 10 hertz it is there, 10 cycle basically in 1 second. So per unit time, so time usually we will be taking as a simple standard unit, that is second only. I hope this is clear. Now, next part is the time period of oscillation, which will be written as 1 by Fn, which is nothing but 2 pi. Okay. Fn value is omega n by 2 pi, omega n will come in denominator, 2 pi will come in numerator. That will give you the time of one cycle. So you might have a question, like they will provide some spring mass system case and they will be asking calculate the time for 10 cycles. Regarding the point, time for 10 cycles they might be asking. So for that what you will be doing? Time period for 1 cycle, that is what time period of oscillation, multiplied by 10 you will get for 10 cycle also. So time period of oscillation is the time required to complete 1 cycle of oscillation or vibration. Frequency is the number of cycles per unit time, and time standard unit is what? SI unit is second only. So in 1 second how many cycles it is having? So that is what we need to calculate. So any of the parameter they might ask. So these relations are very, very important. Now as I told you, we have to understand the D'Alembert principle also. We have discussed only this part, Newton's second law. We have talked about a Newton's second law, but we should also know how to use the D'Alembert principle while writing this equation of motion. That is also very, very important, right? After this discussion only, we will be solving PYQ questions from the vibration topic. And we'll see how to solve those questions, what should be the approach, how to write equation of motion and how to get the omega n answer. So vibration is the most important topic of theory of machine that you should not skip it. And I'm telling you, many students are facing issues in the vibration topic. If basic understanding of writing the equation of motion is clear, you will get the answer very easily. Because this is not direct formula based question that you can easily solve without like knowing the concept. If you just remember the formula, you will get the answer. No, it will not be like this. You have to practice the question and understand the right approach required for solving such vibration questions. So there is no direct formula. We have to analyze it. Okay, and that is what very important here. Okay, now let us see the D'Alembert principle concept also. We will first draw the free body diagram. We will draw the free body diagram first of all. This was the free body diagram. First, we have the self weight mg. Then we have a spring force K delta plus x. Right. Now, as we already discussed that disturbance provided initially in the downward direction. Opposite to that disturbance, like it is initially moving in the downward direction. So acceleration direction would be in downward only. Acceleration direction would be downward only. So that acceleration direction like this. Opposite to this acceleration direction, inertia force will act. This is a very important point that everyone should remember. Opposite to this acceleration direction, inertia force will act. That inertia force will be written as like this. Product of mass into acceleration, and that acceleration can be written as x double dot. X double dot. So we are using the D'Alembert principle concept, right? So opposite to the acceleration or opposite to the disturbance you have provided, we have to apply inertia force. So once inertia force will be applied, if I take the summation of all the forces acting on the body, it would come out to be 0, right? So according to D'Alembert principle, D'Alembert's principle, we can write here all the forces like mg, it is downward. So motion is happening in the downward direction. So mg I have taken first. Opposite to that one, inertia and the spring force. So they will be considered negative because of sign convention. Downward you have taken positive, upward should be negative. So minus inertia force minus spring force, that is k into delta plus x equals to 0. That is there. So D'Alembert principle means summation of forces 0, including the inertia force as well. Including the inertia force as well, right? Now, further, inertia force value mx double dot. Then if you just open up this bracket, k delta minus k into x equals to 0. Now already we have discussed under static condition, mg equals to k delta. Mg equals to k delta value, that will get cancelled out from here also. So finally equation would be mx double dot plus kx equals to 0, right? So that is what the equation of motion we like finally got it from the D'Alembert principle, and that is what same that we have discussed in the Newton's second law also, right? So basic point is whether you use Newton's second law or the D'Alembert principle, answer you will be getting same. Now as we have understood the equation of motion, let us move to the next part, that is in the damped case, damped natural vibration case, what will be the difference will be coming, right? Now next please write down here, damped vibration case where damper will also be involved. This is the damper we have, and then it is connected with the mass m. Now please understand here that spring having stiffness K here, damper coefficient is represented by C. Right. Damper coefficient is C and spring stiffness is K. Now how to write the equation of motion? Directly we can write down here using the same approach that we have used. Okay, that we have used for the undamped case. Same approach we can use it here also. So let's suppose disturbance provided like this x. So equation of motion that we are going to use here is mx double dot plus cx dot, that would be the damping force, then spring force kx equals to 0. This would be the equation of motion for a damped natural vibration. For a damped natural vibration case, this would be the equation of motion. Now, in the same way, if I just divide whole equation with the mass to just make the coefficient of x double dot as 1, you will be having c by m x dot plus k by m x equals to 0. K by m, everyone knows that it is omega n square. But what is c by m? For that, this information that everyone should remember, that damping ratio is written as damping coefficient divided by critical damping coefficient, C by Cc, right? Now, damping coefficient is C. What is C? C, that is critical damping coefficient, which can be written as 2m omega n. So directly I am writing the formulas here, that is very important for the vibration analysis part. C by divided by 2m into omega n. 2m omega n is the value of critical damping coefficient. So what is the value of C by m we can write here? C by m can be written as 2 into damping ratio multiplied by omega n. Same value I can substitute here so that the equation will change in this format. X double dot C by m is what? 2 psi omega n into x dot plus k by m. Instead of k by m, we will be writing omega n square into x equals to 0. So this is what the main equation, and then finally we have modified into this format. So this equation of motions are very important, that everyone should remember, right? Now this equation we have written for a simple linear case. If it is what? A rotation case, in that case what will happen? What are the changes that you will see? This is also very important point. This is a simple linear motion case, in that this equation would be there. In rotation case, how this equation will change? So in case of rotation, instead of mass moment of inertia would be coming, right? So let us write down that equation also. So first, for a linear case I am writing And for rotation case, we can write it like this: I theta double dot plus C theta dot plus K theta. This is the equation, right? These are the equations for the damped natural vibration case. Now, similar rotation case also we can write for this without damper also. Without damper, what would be the equation? Let us write it here directly. I theta double dot plus K theta equals to 0. So that would be the equation for the rotation case without any damper. I hope this one is clear to everyone. This is what very important to understand, what are the equations of motion we have, right? So this is what very important equation: mx double dot plus cx dot plus kx 0. For a linear case, for rotation case, I theta double dot plus c theta dot plus k theta equals to 0. Now we'll be directly moving to the numerical parts that came in the previous year examination. Let us see the first question here. This was the first question that we are going to discuss coming in the GATE examination 2012. Right. What is the approach that we need to use here? See, they've given a concentrated mass here in the middle of the rod. They have kept, there is a spring here. What actually they are asking? They are asking the undamped natural frequency of the system. So to get the frequency of this undamped natural case, undamped natural vibration case, what do you need to do? You have to disturb the system from its static equilibrium equation or the condition basically. You have to disturb the system from its static equilibrium condition. After providing disturbance, you have to write down the equation of motion. Once you have written equation of motion, then you will get the answer very easily. As there is no damper, the standard format of equation that you will be getting would be like this. This kind of equation you will be getting. And then whatever coefficient you will be having with theta, that would become omega n square if theta double dot coefficient is 1. Right? That is what we need to do. So let us see how the question we will be solving in this case. So natural frequency for this case we need to calculate. And before solving this question, please understand, they have mentioned a concentrated mass M attached at the center of the rod. Apart from that, neglecting the weight of the rod. Weight of the rod we have to neglect. Only that concentrated mass we need to consider. Right. So I will initially provide the disturbance to the system. So that disturbance to the system, we can provide it like this. See, let's suppose this kind of disturbance I provided in the anti-clockwise direction. So this is what the disturbance provided. Theta. Theta is the disturbance provided to the system. Right? Theta is the disturbance provided to the system. Now, what will happen? Opposite to this disturbance theta, there would be a inertia torque. In this case, force will not be coming, torque will be coming because rotation we are providing. For that, a torque would be required. Opposite to that, inertia torque will come. How we have discussed the D'Alembert case? You have provided disturbance x, inertia force come. Here, rotation we are providing, inertia torque will come. Opposite to that. That will be written as I theta double dot. Now, when you will provide the disturbance like this, tell me what will happen to the spring? The spring will get elongated. Obviously, spring will get elongated. By how much distance? Simply 2L into theta. That is the distance. That would be the elongation happening in the spring. So, because of that elongation, spring force will be developed. And spring force always developed in such a way that it will oppose the deformation. So deformation happening like this, opposite to that deformation, spring force will act. So spring force will be acting like this. So that spring force also create a moment about this point, hinge. So that moment would be written as Fs, that is a spring force multiplied by the total distance 2L. So these are the two total torques that we are going to add, so that we'll get the equation of motion. So I will be adding all the torques including the inertia torque. And if I add, final answer should be 0 after adding it. And from that equation of motion we will be getting. So let us see how we will do that. Inertia torque I theta double dot plus that spring force Fs multiplied by 2 into L. 2L is basically the distance because that is the spring force at this point. Moment would be calculated just by multiplying 2L with the Fs value. Right. Now, so you might be thinking, sir, the weight of this small mass is not considered. So please understand, this is a most common misconception, always a we will say misconception here. Why? Why it is there? Because you would be thinking, sir, there would be a weight component mg. It is also creating a torque here or the moment. So that would be mg into L. Why you are not considering this one also? It will not be considered because under static condition mg into L torque or the moment value about hinge is already balanced by the spring force moment. So if I am talking about a static condition, that moment would be there. In that case, that moment will get balanced by the moment of spring force about the hinge only. So always remember, when we are calculating natural frequency, we are disturbing system from its static condition. And when we are disturbing the system from its static condition, whatever forces that is acting in the static equilibrium conditions, that are not considered. For example, once we have written the equation like this, mg was the force, but why it is not coming in the equation of motion? Because that mg force, downward force, already get balanced by the k delta value. So if you see the equation of motion here, why mg is not coming? Because it is already balanced under static condition. So those forces which is already balanced in the static condition, that will not come into the equation part. Please take care of this part, very important. Right. So let us finally write down the answer here. So mass moment of inertia about the hinge. So this is a concentrated mass. About this point, mass moment of inertia would be ml square. That would be ml square. Okay. Because the distance of that concentrated mass from the hinge point is only L. So that's why mass multiplied by distance square from the point of rotation. Spring force, stiffness K multiplied by 2L theta is the deflection happening in the spring. This is the spring force multiplied by the distance 2L will give you the moment. Okay. So ml square multiplied by theta double dot, it is also there. So finally, theta double dot plus k into 2L, 2L into 2L, that will be 4L square into k divided by ml square into theta. Now, as I already mentioned, this is the standard format. This equation is the standard format. So whatever the coefficient you will be having with theta, that is omega n square. And because coefficient of theta double dot, we have make it as 1 only. So coefficient of theta double dot is 1. So whatever coefficient you will be having with theta, it would be omega n square only. So you can write finally omega n answer as under root L square will get cancelled out. So 4k by m would be the answer for this particular case. I hope this is clear to everyone. So you can just check the options, which of the options would be correct in this case. Option number D will be the correct answer here. So very simple approach that we have taken here is, from the static equilibrium condition of the system, you have to disturb it. Initial disturbance you have to provide. Disturbance provided in anti-clockwise, opposite to that inertia torque will come, which is I theta double dot. And remember, where the mostly mistakes will happen is I, while calculating I. I is the mass moment of inertia taken about a point where the rotation is considered. Again I am repeating, I is the mass moment of inertia of the system about a point where the rotation is considered. This is the most common mistake that would be happening while calculating I. So make sure that you are not doing any mistake in the calculation of I, right? So from there you will get the answer of this 4k by m. Okay, so 4k by m is the answer. Now moving to the next numerical, this one. Please understand this one again. A rigid uniform rod AB of length L and mass m is hinged. Mass m they have mentioned for what? Rod here. A rigid uniform rod AB of length L and mass m. Rod is having mass m, hinged at point C, such that AC length is L by 3, remaining would be 2L by 3. What we need to calculate? Natural frequency of the system. Again, what you need to do? You have to disturb the system. So how we will disturb the system? Let us see again what we are going to do. We will give the disturbance to it. Let's suppose clockwise rotation I have provided like this. This kind of clockwise rotation I have provided. Okay. Now clockwise rotation is provided. So this much would be the deflection happening in the spring. This much deflection happening in the spring. Deflection or deformation happening in the spring, spring force will develop. Now please tell me the very important point. On the left side of the spring force will be acting upward or downward? Spring force acting in the left spring, it would be upward or downward, that you need to decide. Similarly, spring force acting in the right spring, whether it is upward or downward. Just please think about this point. I already mentioned this point that spring force always developed to oppose the deformation happening in the spring. It is going to compress because of the rotation provided clockwise. This spring is going to compress. To oppose that compression, spring force will act downward. So that would be the downward spring force will act. Let's suppose I am writing Fs1. In this case, what will happen? Elongation. To oppose that elongation, spring force will act in the upward direction. Let's suppose I am mentioning with Fs2. Right. So the equation of motion, okay, but before that, clockwise is the disturbance provided. Opposite to that disturbance, inertia torque. I theta double dot. Right, I theta double dot, it would be there. Then after this, spring force Fs2 will create a moment here, anti-clockwise. This Fs1 also will create anti-clockwise moment. Both the spring force will create anti-clockwise moment about the point of rotation, that is C. So we will write like this. Fs1 multiplied by how much distance? L by 3. Then again anti-clockwise moment by Fs2 force. How much distance? 2L by 3. We will just add all the values here. Okay. We will add all the values of the torque and we'll get the equation of motion here. So please understand, you just need to give the disturbance to the system. After that, what is required? You need to consider all the torque that would be acting in the system and add all the torque values including the inertia torque, and we will equate with 0. You will get the equation of motion. Hi Saurabh, one reply. Okay, you have to reply the answer also. Like we are discussing the vibration questions, right? So what would be the answer? So parallelly you should be solving the question, right? So what we will be doing, inertia torque and all the torque values we are going to add here. So if I add all the values, the equation of motion would be I theta double dot plus the torque or the moment value of the Fs1 is Fs1 multiplied by L by 3, Fs2 multiplied by 2L by 3 equals to 0. Right? This is the equation. Correct, everyone? Now, I value, that is the mass moment of inertia. I, that is the mass moment of inertia value about C, we have to calculate. I am a dropper, Jay. So, mass moment of inertia, I hope you know already this point, how to calculate the mass moment of inertia of a rod about point C. That mass moment of inertia, it is what required here. So mass moment of inertia is a very like a common concept in the school physics, already we have discussed, and that would be there always. Wherever the rotation comes, mass moment of inertia will come. So mass moment of inertia calculation is required about point C. Okay, so first we will calculate that part. Okay, because always remember rotation happening about point C, so all the values we are calculating about point C. So mass moment of inertia also about point C. To calculate the mass moment of inertia about point C, first you will be writing the mass moment of inertia about the center point of the rod. So let us understand how to write this mass moment of inertia value. So let me draw it separately. This is the center, for example. Center point is O and we have to calculate about point C. Distance between distance between from the C point, distance between point C about which we want to calculate mass moment of inertia from the center of rotation. Okay, C is the point about which I want to calculate mass moment of inertia. O is the center of the rod, geometric center basically. Geometric center of the rod is O, right? And we need to calculate about point C. Parallel axis theorem we have to use here. Parallel axis theorem. Okay. So mass moment of inertia about C will be written as mass moment of inertia about the geometric center O plus mass multiplied by the distance square from the point about which I want to calculate from the point which is the center CG point basically, or center of gravity point. That would be, okay, total distance is L by 2, this much is L by 3. It should be L by 2 minus L by 3. Okay. Like this. With the help of parallel axis theorem, we can easily calculate, right? So, mass moment of inertia about the geometric or the CG point, that would be ml square by 12. This formula we should remember. L by 2 minus L by 3 would be L by 6 whole square. So, it would be 6 square would be 36, right? 36 it is there, 12 it is there. So, 3 multiply and divide, it would be 4 ml square by 36, and finally you will be having as ml square by 9. That is the mass moment of inertia about point C, or basically the hinge point. C is the hinge point about which we have calculated the mass moment of inertia using the parallel axis theorem, right? About the CG or the geometric center point O, the mass moment of inertia is ml square by 2 plus mass multiplied by distance square. Distance of the point about which point we want to calculate, the point about which I want to calculate the mass moment of inertia from the geometric center point or the CG point. I have taken the distance, that is L by 2 minus L by 3 square I have done, and then added with the CG value, mass moment of inertia value about the CG value. We have added this value with the mass moment of inertia about CG. Through that we got the answer here. Now, once we have solved this value, I will substitute here and I will get the answer very easily. Okay. Now, let us put this value in this equation. I value we got as ml square by 9 theta double dot plus fs1. What is fs1? K into L by 3 theta, because the deflection that would be happening here would be L by 3 multiplied by theta. This is what theta here. This is theta. So let us write K into L by 3 theta multiplied by L by 3 plus K into, in the case of fs2, in the case of fs2, 2L by 3 into theta would be the distance. (2L by 3 into theta multiplied by 2L by 3 to get the value of moment. Right? Clear everyone? So this is the equation of motion finally. ml square by 9 theta double dot plus it would be k L square by 9 theta plus it would be 4 k L square by 9 theta equals to 0. Now k L square by 9, 4 k L square by 9, it becomes 5 k L square by 9, and I can write this equation directly here, keeping theta double dot coefficient as 1. So dividing the whole equation by this value, right? So that becomes the 5 k L square by 9 divided by ml square by 9 into theta equals to 0. I hope this point is clear. Okay. So from here, omega n answer directly we can write. That would be the under root of this value, because this is omega n square. Omega n value would be under root of this one. Right. So 9 and 9 will get cancelled out. So answer would be under root 5k by m radian per second. Under root 5k by m will be the answer here. Mechanical world 5k L square by 9. This addition would be 5k L square by 9, but divided by ml square by 9. Final answer would be under root m into k by m. Correct? I hope this point is clear, everyone. So we got the answer here as under root 5k by m. So it is like very simple that we have discussed. ml square by 9 was the mass moment of inertia value. By adding the spring force moment, we got 5kl square by 9. kl square by 9, 4kl square by 9. Resulting value would be 5kl square by 9 divided by ml square by 9, and root 5km would be the omega n answer. So if you see the options, under root 5k by m, that is option number D is the correct answer here. So again I am telling you, in this question the process is very important. If you have understood the process, then any of the question of natural vibration case you can easily solve. Now moving to the next numerical. Again similar kind of question, but there is a small difference. If you compare this question with the previous question, similar kind of question, but in the previous question mass was not there. In this case mass is placed. So just compare with the previous question. There was a rod having mass m and the two springs connected upward. In the next numerical it is connected downwards, no issue. But there is no additional mass. In the next question additional mass is placed here. The only difference that you will see in this question is the mass moment of inertia value. Only that is the difference will come here. Okay, so first we will calculate the mass moment of inertia. Again same thing, natural frequency of the system we have to calculate. Okay. Now, first of all, mass moment of inertia about point O we will write. But it includes two things, rod plus that small mass m. So mass moment of inertia of rod plus mass moment of inertia of the mass m, small mass m. And they have given a relation also, please understand. This relation also they have given. M equals to, small m equals to capital M by 4, that relation is there. And in the option if you check, only capital M they have mentioned. Only capital M they have mentioned. So I need to replace small m with the capital M. That point we need to ensure. Now, first of all, mass moment of inertia of a rod about point O. About the geometric center or about the CG, it is ml square by 12. Okay, capital M plus m into distance square. Which distance square? Distance of CG point from the point of rotation, or the point about which I want to calculate. That would be L by 2 minus L by 3. This is for rod. Now for mass, this is a small concentrated mass. The mass moment of inertia of this mass about point O would be the mass multiplied by distance square. Small mass m. Distance is 2L by 3. Like this. We will replace small m with the capital M. Already relation they have mentioned. Particle mass small m is capital M by 4. Capital M is the mass of rod. So if you solve, so ml square by 12 plus m into L by 2, L minus 3 is L by 6. Six square would be 36. Instead of small m, capital M by 4, we will be writing 4L square by 3 square is 9. 9 into 4, 36. This is 12. Take the LCM same. We can make the LCM same here. So that would be 36 in the denominator. So 3 we need to multiply 3 plus 1. Okay, directly we will calculate. Already 4 it is there, 3 it would be there, 1. So 3 plus 1, 4 and 4, that is 8. 8 ml square by 36, which can also be written as 2 by 9 ml square. This is the mass moment of inertia. And obviously one thing you will observe, the mass moment of inertia value increases compared to the previous case, and it will increase for sure. Why? Additional mass you have kept away from the point of rotation, it will increase the mass moment of inertia value. It will increase for sure. So this is the resulting mass moment of inertia value of the system. System means rod plus mass. Now after that, disturb the system, write down the equation of motion, you will get the answer. Let us solve this one also. Let us provide the disturbance in the clockwise direction like this. Okay. So now this is what compressed. Spring force will be acting upward. This is elongated. Spring force will be acting downward. Okay. Let us consider Fs1. Here it would be Fs2. This angle turn theta, this angle turn theta. Now, disturbance provided theta, opposite to that disturbance inertia torque I theta double dot. Clear everyone? Now, Fs1 and Fs2 both will create anti-clockwise moment about point O. Fs1 multiplied by L by 3. Fs2 multiplied by 2L by 3. Both are in the same direction. Both the moments value are in the same direction, right? So that values of the moments, all the torque values I will add and equate with 0 because inertia torque I have added. So total summation of torque value has to be 0 using the D'Alembert principle. So let us write that one. Fs1 multiplied by L by 3, Fs2 multiplied by 2L by 3 equals to 0. Now what is the mass moment of inertia value? 2 by 9. Fs1 answer, K multiplied by L by 3 theta. Plus K into 2L by 3 into 2L by 3 like this. This is what the equation of motion. Finally, we will simplify and try to convert into standard format. So if you are able to convert into standard format, then it would be very easy to get the answer of omega n. Very easily you can get the answer. Let us see how. So this would be KL square by 9. This one would be 4 KL square by 9. 4 KL square by 9, this is KL square by 9. Now theta double dot will be written as 5 KL square by 9 divided by 2 ml square by 9. This is the standard format. Theta double dot coefficient is 1 and the coefficient with the theta will be the omega n square. So omega n would be the under root of this particular value. That would be written as like this, under root of this 5k by 2m. Because that 9 and 9 will get cancelled out, L square and L square will get cancelled out. This is what the answer we got finally, and that is, we will see in the option which option would be correct here. right, radian per second. So option, if I check here, option number B will be the correct answer here. You can just cross check your answers as well. Option B, under 5K by 2M will be the correct answer. So just please observe this part. This question came in 2017, right? And the previous question, if you see, it came in 2014. Similar kind of question came, exactly similar. Small addition they have done, that they have put a small mass here. That's why I'm always saying this point. Please, you have to solve the PYQs. Not just solve, you need to learn the concept from that each and every PYQ questions. Just in front of you, I've told you one example also. 2014, this question came. In 2017, same question with small changes. So if you have practiced the PYQ very well, and if small modification they have done in the previous year questions and that came in this year also, you will be easily able to solve the question if you have understood the concept. Not just solving it, you have to learn the concept from the each and every numerical that came in previous year. Because if you have mastered all the questions or everything, you have understood and prepared well all the PYQs, so there would be here and there small modifications in the new questions, you will be easily able to do it. Right, please remember this part. More and more practice if you do, more and more confident you will become, and that confidence matters a lot in the preparation of the GATE examination. It's not just you will remember formulas and you will get all the answers. That will never possible. That is totally never possible that just by remembering the formulas you will solve all the numericals, right? You have to practice. You need to understand how I will use the formula in the given situation and what kind of analytical analysis is required to come to a conclusion, right? So this is what expected from every engineer here. So that's why this GATE paper, the definition, if you see, the complete full form of the GATE is the graduate aptitude test in engineering. It is aptitude test in engineering. It's not checking your knowledge actually, how much you are able to apply the concept in a real life situation. That is what they are going to check. So based on the knowledge, they are not just checking your knowledge, they are actually checking your aptitude level in the engineering concept. That is what required here. And that's why you will observe that theoretical questions are very less compared to the numericals, and even if theoretical question comes, that would be at the surface level. They will never ask a question, theoretical question, which is in depth, like a very in-depth question they would be asking, never in theoretical. But a numerical they will be asking where totally aptitude would be required, technical aptitude would be required to solve such questions. Now, next problem. This is also again very important, came in this GATE examination only, right, 2019. Natural frequency of the system they are asking. Same concept, same process we are going to use. We will disturb the system. We will disturb the system from its static condition, static equilibrium condition, and after disturbing the system, we will see how to get the answer of the natural frequency. To get the answer of natural frequency, we have to write down equation of motion in standard format, right? So again, same thing, K1, K2, different values they have given. Natural frequency we have to calculate, round off to 1 decimal place. Round off to 1 decimal place they have asked. Right, now let us use the concept here. So this is initially the vertical line. Now if I provide the rotation, that will be happening what? Like if I provide a rotation, this would be like this. It would little bit inclined, okay? It would turn basically. Initially this line is vertical. If I provide a rotation to the disk, this line would be like this now. So let's suppose some rotation provided. How much rotation you have provided? Let us mention here theta. Theta is what the rotation you have provided, clockwise. Clockwise theta rotation we have provided. That is the disturbance. Theta disturbance we have provided in the clockwise sense. Opposite to that theta disturbance, what will happen? Inertia torque will come. Okay, opposite to that theta disturbance, inertia torque is going to come. So let us mention inertia torque like this, I theta double dot. Right? Is it clear? Simple. Now, spring will get deformed, so definitely spring force will also develop. This is going to elongate, this is going to compress. Elongation happens, what will happen? There is a spring force acting like this. Let us mention this Fs2. Please mention this one as Fs2. Spring force get compressed here. Okay. Elongation happens in this case. So spring force will apply in such a way that it will oppose the elongation happening in the spring. But the upper spring, so let us mention the name as it is, because the stiffness K1 they have mentioned, right? So this is Fs1. This is K2. So Fs2, but it is getting compressed. To oppose that compression, spring force will act like this, Fs2. Is it clear? Right. So Fs1 is the force that is developed in the spring having stiffness K1. It is getting elongated. To oppose that elongation, spring force Fs1 will come. Similarly, in K2 spring, the spring having stiffness K2, it is getting compressed. To oppose that compression, spring force Fs2 will come. Now, we will write down the equation of motion here directly. Now, both the spring forces will have a moment about this point. This is a point about which we need to write down the moment. Okay. So, that is Fs1 and Fs2 both will have a same direction. Fs1 multiplied by radius r, but Fs2 multiplied by the diameter, that is twice of radius. Fs2 multiplied by this much distance, Fs1 this much distance. Accordingly, Fs1 into r, Fs2 into 2r. Right? This is what we need to understand. Very basic part. Now, all the things we have mentioned, now please write down the equation of motion here. I theta double dot plus all the moments are in the anticlockwise, so Fs1 into r Fs2 into 2r equals to 0. Right? Clear? Now, mass moment of inertia about this point of rotation. So for that, again, parallel axis theorem we will be using. So how to get the mass moment of inertia? See, this is a circle we have. Okay. So about this point, center, CG point, geometric center, and this is a point of contact C, about which I want to calculate. About the CG or the geometric center point, mass moment of inertia of a disk is mr square by 2. To calculate about this point, parallel axis theorem is required. Okay, so to calculate mass moment of inertia about C, I will write it like this. Distance of point O from C is r, so mr square. Mr square by 2 is the mass moment of inertia about the center. This one would be 3 mr square by 2. This is what the calculation that we should remember. Right? I hope this basic part is clear to everyone. So let us keep it here. Okay. Now, this value is 3 by 2 mr square. Fs1. What is Fs1? Please understand. Fs1 is K multiplied by this much r into theta. K1 into r theta into r. Fs2 K2 multiplied by 2r theta and to get moment we will multiply 2r. Right? Okay. So this is 3 by 2 mr square, as it is we will be writing. Now k1 into r square theta, and here k2 into 4r square theta equals to 0. So theta double dot will be written as k1r square plus k2 into 4r square. So we'll be writing directly k1r square plus 4k2r square, taking common the theta part here, and remaining thing we will write it here 3 by 2 mr square. Okay. Now in this part I hope you understood that r square value will get cancelled out. Now the values that they've given for k1 k2 is k1 400, k2 is what, 100, k1 400 they've mentioned, so equals to 0. So this is what the omega n square value, omega n value will be the under root of this one. So let us write that one. So it would be k1 plus 4k2. k1 plus 4k2 divided by 3 by 2m. Right. Now k1 value was given as 400 and k2 was 100. So let us put the values. Three by 2 into mass value. Mass 1 kg they have mentioned. So that mass we will be putting here. So just we have to do this calculation and we'll get the answer. Okay. So let us calculate this part. So that would be 800, okay, in the numerator, multiplied by 2, that would be 1600 divided by this is 3. So if I solve this one, it is coming as 23.09. radian per second. So I can mention, because the answer they have asked in round off to 1 decimal place. So I should be writing here 23.1 radian per second, because up to 1 decimal place they have asked. This is what the answer we got finally. Right? This is also clear, I hope. So we have solved some of the PYQs from the natural frequency question, questions for the damped as well as undamped also. Damped case already we have discussed the equation, how to write equation for damped case. If that kind of question will come, same approach we are going to apply. Only one thing that is additional coming is damping force, that is C into x dot. That is the damping force that will come additionally. I hope till this point everyone is clear. So we have solved this questions. These questions I am telling you, natural frequency questions are very easy if you have understood the approach. The first thing is you have to consider the static equilibrium condition. After static equilibrium condition, you need to disturb the system. After disturbing the system, you need to write down the equation of motion using the Newton's second law or the D'Alembert principle. So when I am writing D'Alembert principle, I need to ensure that all the force summation, including inertia force, it would be 0. If it is a case of rotation, all the torque value plus, or that is including inertia torque value also, it would be 0. So that principle, D'Alembert principle, we can use to get the final answer. Now one more question we will be solving that came in GATE 2022. Again a very interesting question, but I would say this would be difficult if you don't know how to write down the mass moment of inertia of a circular disc. Okay, and this is what a kind of a ring, annular disc it is there. Okay, so two different radius, small r and capital R they have given. First, writing the mass moment of inertia is very important here. Forget about calculation of the natural frequency. If you don't know how to write mass moment of inertia, then you will never get the answer. So first we will understand how to write down the mass moment of inertia for this case, and what actually they are asking. They have mentioned the time period of oscillation like this. In that they are asking the value of beta. So what I need to do, calculate the time period of oscillation, represent time period of oscillation in this format, and then calculate the beta value. Right, so that beta value we will be getting for that time period of oscillation. For writing time period of oscillation, omega n is what required. So omega n only we have to first solve, and then we will calculate beta as well. Right. First we will understand how we will disturb this system. See, initially it is like this. Now if I provide anti-clockwise disturbance, it would rotate like this. It would rotate like this. This is what the disturbance provided, theta. Opposite to that, inertia torque will come. Apart from this inertia torque, is there any other torque will come here? Tell me. Is there any other torque? Definitely it will be coming, because that center of gravity point is going to change, or it is going to shift from here to here. From here to here it is going to shift. This is the new point of center of gravity. So that will create a moment about point A. And in which direction it would be creating? In clockwise direction only. It would be written as mg into, what is the distance of G point from point A, small r? R theta only. Very simple. So writing the equation of motion here, I theta double dot plus torque because of mg weight equals to 0. That is what equation of motion. Now the main task here is to calculate the mass moment of inertia about point A. That is the main task. So for that, please everyone, you should understand, for writing the mass moment of inertia value of a circular disc, or we can say a ring here in this case, you need to remember one formula here. Okay. Now let us consider this is radius r1, this is radius r2. So mass moment of inertia in this case about the CG point will be written as m r1 square plus r2 square divided by 2. This is the formula that everyone should remember. Mass moment of inertia of a ring case having radius r1 and r2. If r1 and r2 are approximately, or we can say both are equivalent only, in that case mass moment of inertia would be mr square only for a ring about this point CG. So x is passing through the CG and perpendicular to this plane. Right, like this. Now please understand here, r1 r2 values are what? R1 is small r, R2 is capital R, and they have given the relation also. That relation is small r square equals to capital R square by 2. That is the relation they also have given. So that formula I will apply in this case for writing mass moment of inertia about point A. Now if I have to calculate here directly, this formula would be applicable, but now I have to calculate mass moment of inertia about this point A. So I need to use parallel access theorem now. If they have asked about this point, directly I will use this formula, but now they are asking about this point, any other point. Okay, they are not asking about this G, because that G, the rotation is not happening. Rotation happening about point A. So about point A I will write mass moment of inertia. So about point A, mass moment of inertia you will be able to calculate with the help of parallel access theorem. So let us write that part. First this one, small r square plus capital R square by 2 about CG we have to write first, then mr square. The distance of G from point A, that is small r square. Now small r square is nothing but capital R square by 2. capital R square by 2. Now you just need to calculate this value, you will get the answer very easily. So small r square was capital R square by 2. So instead of small r square, capital R square by 2 I have written. If you take the LCM, 3mr square by 2, 2 and 2, that would be 4. Plus this is mr square by 2. So if you take the LCM, it would be 5 mr square by 4. This is the mass moment of inertia. Now equation of motion is like very simple. This value only we need to keep it here. Then we get the answer of omega n using omega n time period of oscillation, and then equate with the relation that they have given for time period of oscillation. With that, if I relate, I will get the answer very easily. So let us do that. mg into r theta. R is small theta, so instead of small r, capital R by root 2, it would be there equals to 0. mg r by root 2 divided by 5 by 4 like this, right? This is there. Now this value is nothing but omega n value. So if you simplify, it would be 4, right? This is mg here, so we should keep the g value also. We have not kept the g value, g into r, because mg into r by root 2 it is there, right? So 4 goes to numerator, this m and m will get cancelled out, this r, see this m cancel out, this r will get cancelled out, and this power, instead of power 2 it would become 1. So it would be 4 into g divided by 5 into root 2 into r. That is what the omega n answer, first of all. That is what the answer of omega n. So 4 goes to the numerator, 4 into g, 5 multiplied by root 2, and r is already there. So 5 into root 2 into r, and in the numerator 4g. So that is omega n answer. Now to get the time period of oscillation, to get the answer of time period of oscillation, please see, that would be 1 upon frequency in hertz, that is nothing but omega n by 2 pi. So 2 pi by omega n is the time period of oscillation in second. So let us calculate the time period of oscillation. 2 pi, I will keep it separately. Omega n, that will come here. So numerator part will first come in the denominator, that is 4 into g. In the numerator it would be 5 into root 2 into r. Now just equate with the value that is given in the question. Just equate this value with the question. Question basically means the data given in the question, b into beta into pi into root r by g. Beta into pi under root r by g. So under root r by g I need to keep it separate. Again let us check. Beta into pi into under root r by g, it is there. So it is there, just we have to keep the things like this. Separately I will keep pi into root r by g beta into pi root r by g. So whatever the value will be coming here, that numerical value, that becomes the beta value. So if you just solve, you will get the answer here. So we have, okay, 4 and g will be there inside, but 4 will come outside, 2 will get cancelled out. So first of all 5 into root 2 value we will calculate, then under root again we will do, and this 2 and 2 will get cancelled out because 4 will come outside 2 and 2 cancel out, pi will be as it is. So it is coming 2.659, like this it coming. So finally we can mention from here, that beta answer is 2.6. So let us check up to what decimal place they've asked, 2 decimal place. So now I can do the round off, so it would be written as 2.66. This is what the answer of beta. Again, a very simple question, right? So I'm telling you, in all natural frequency questions, you need to know the process. First, consider the static equilibrium condition of the system, disturb it, write down the equation of motion using D'Alembert principle, and then write it in a standard format, and then you will get the answer very easily. The most important part where mostly many people are doing mistake is writing the mass moment of inertia value. The point of rotation you have considered, about the same point of rotation, you need to write down the mass moment of inertia value. So don't do mistake in that part, right? So I hope you have understood all the questions that we have discussed so far, right? So we have discussed the damped natural frequency cases, undamped natural frequency case also I've talked about with the equation of motion that we have written. If damper is involved in such cases, you can again use same process, same procedure. You will get the same answer. The only difference is the damping force that is coming additionally. That is the only difference, right? I hope you have understood the concept of natural frequency quotients, and now it would be clear, no matter what kind of question they have asked related to this natural frequency, you will be able to solve it. So I hope you have enjoyed the lecture here, right? In tomorrow's session, I will be taking engineering mechanics dynamics part. So we will be discussing some of the important concept of engineering mechanics that is related with the dynamics part, which is very important for mechanical engineering students. And we will solve some of the very important questions that came in the previous year GATE examination. Important PYQ questions we are going to discuss in tomorrow's session for engineering mechanics from the dynamics part. Please remember, dynamics part we are going to discuss, because that is the part where many students are facing trouble. So many challenges they are facing there. Stress, friction, equilibrium, these are like very easy part. In dynamics, the problem is how to apply the correct equation, how to use relations, how to start solving the question, what is the first step required. Everything is what completely, like many students are going blank there. They don't know how to start the question, how to start solving that particular numerical engineering mechanics, because hardly 3-4 formulas are there in engineering mechanics, but the variety of question is huge. So in engineering mechanics, the point is you need to understand the motion, and if you have understood the motion, then you can apply the correct equation or the relation. The problem is we have not understood the motion that they are talking about in the question, and we are thinking which formula we should apply, and that is what the problem. You have to first visualize the motion happening, then only you can apply the correct relation, right? So I hope you have enjoyed the lecture here, and there is important information for you guys. As I already many times have discussed, that test series plays a very important role in the GATE preparation part, right? Without giving the test series, you cannot prepare for the GATE examination, because it will help you to analyze what kind of mistakes you are doing, what are your strength, what are your weakness. Everything will be clear if you are giving the test series. So there is a test series product that IMS GATE Academy is offering you, where you will be getting 130 plus online test. You will be getting not only the subject test or the full length test, you will be getting chapter test as well. That is what the unique feature of the IMS GATE Academy product. And the main part of it is, you will be getting with this IMS GATE Academy test series plus product, you will get the direct PYQ book. Previous year question booklets you will be getting, not 1, 2 booklets you are getting, one for technical subject and the second one you will be getting for the maths and aptitude part. So that is a very good combo product that you can easily like purchase from the IMS GATE Academy website, right? Now apart from that, you will be getting, see, other features that which is very important. One is doubt solving portal. It is very important. While practicing questions, you might get some doubt. So just you need to take the photo of that image, post in the portal, you will be getting the solution immediately there. So you can use that features as well. Now coming to the next part, that what are the features that we have in the IMS GATE Academy test series plus product and the only test series product. You will be getting all the features. Apart from that, you will not get the books, you will not get the two books basically, technical book and aptitude book, and you will not be getting the mock interview sessions in the test series product. But in test series plus product, all the features that is mentioned here you will be getting. So you can take this product and you can make your preparation in such a way that you will get a very good score in the GATE examination. And that test series is only the key for success. Key for success in GATE examination is practice, and practicing through online test, that is very important part. Okay. Now, next announcement that we have is IMS GATE Academy has launched the new batches for GATE 2026 and 2027. So you can directly enroll in the IMS GATE Academy live online programs, which offers you more than 800 hours of session. You will be getting 12 one-to-one mentorship sessions. Apart from that, you will be getting the test series product part also, right? So if you are interested in the live online program for GATE 2026 and 27, you can directly call on this number and you can book your free counseling session where you will be getting each and every detail regarding the GATE preparation. You can directly call on these numbers as well. And apart from that, one more thing that we have is the Telegram group. So you can directly join the Telegram group using this link where you will be getting this session PDF as well. So whatever we have discussed today, all the questions that you will be getting in this Telegram PDF you will be getting, because you might be listening, you have not noted down the solution part. You will get the direct access of the PDF if you join this particular Telegram group. And apart from that, whatever upcoming YouTube sessions we have planned, all informations you will be getting. And also, latest job notification. You should not be worried about the job notification part. Everything you will be getting in this particular Telegram group. And also, daily quizzes are running, which will help you in your GATE preparation as well. So thank you so much, guys. I hope you have enjoyed the session. We will meet tomorrow again, same timing, 5 p.m. for the dynamic session on the engineering mechanics subject with important PYQs. Thank you so much.